Hello everyone. Today we'll be reviewing a position function and seeing how it corresponds with the functions of velocity and acceleration. We will start with the given function of a particle according to the laws of motion, where s equals f of x and s is feet, f of x will be the output, where x is going to be t and t is seconds, and t is greater than or equal to 0, t is measured in seconds, and s is in feet. The function of the position function for our example today is going to be f of t equals sine of pi times t over 2. We will use this function to find the velocity at time t because velocity is also known as the rate of change of an object. By finding the first derivative of the original function, and that original function is continuous and differentiable on all real numbers on the interval, we will be given the slope of a tangent line at any point on the original position function. So to find the first derivative, we will first start by inputting our value of t's, and I like to use the substitution rule when I'm using the chain rule, and I substituted pi times t over 2 with the u, and I put that off to the side over here. And now we start finding the derivatives of our parent function, which is going to be cosine of u, and we know that the chain rule requires us to multiply the inner function again on the outside. So we're going to label that as u prime, and now we will find u prime, and we will do that using our division rule, which is where you have to find the derivative of f of x over g of x, which is what we have here, as t over 2 is going to be that said function. So we start with g of x, which is always going to be 2, times 1, because f prime, which is our t value, has an exponent of 1, therefore you bring it to the front, and t is dissolved, and we subtract it by f of x, which is our t value, times g prime of x, and we know that the derivative of any constant is always 0. And for our denominator, we have g of x to the second power, which we will input 2 and square it. Looking back at our original function, we have cosine times our u value, which is pi times t over 2, and we're going to multiply that by pi over 2 because we can simplify our u prime back down to pi over 2. I'm sorry, I forgot to include the original pi from the statement in what we do with it. You're able to bring pi out because it is a constant and it is not a part of the family of functions that we have later on in this u value. So the pi should always be there. And upon simplifying, we find that pi over 2 is what our u prime is going to be. So now we have found the first derivative of our original function, which we can also call the slope of the tangent line at any given point. And today we are going to be finding the value of that slope at 3, because in our case, we are trying to find the velocity of our particle after 3 seconds. So we will go ahead and do that by inputting 3 as our t value, or our time value, and continuing to simplify this out. We know that cosine of 3 pi over 2 is going to be 0, because if we go ahead and look at our unit circle here, I don't know how well it's going to show. Right here, because cosine is always the x value, we can go straight down, and we know that it is 0. So we now know that after 3 seconds, the velocity of our particle is probably going to equal 0, because anything times 0 is always 0. So again, the velocity of our particle after 3 seconds, according to our function, is going to be 0 feet per second after 3 seconds. And from this, we can try to figure out when our particle is going to be at rest. And we will do this by, again, looking at our unit circle, and we are going to try to find any points where cosine is going to equal 0. And we know that cosine equals 0 at 3 pi over 2, as well as pi over 2. And we know these to be, I guess you could say, the odd intervals of our unit circle. So in order to have our particle be at rest, we need to either land on 3 pi over 2 or pi over 2, or have our trigonomic function equal 0. And we can do that by finding any odd integer where n is a non-negative and our velocity will always equal 0. We can use this little formula to find our t's, because we will always land on 1 or 3 or 5 or 7, and in all of those cases, cosine of pi times any of those odd numbers over 2 are always it's going to end up to be 0, because we are first multiplying it to find the double the original integer, such as 1, for example. If we plugged in 1, we would find 2 times 1 is 1, plus 1 is 3, and that's how we get 3 pi over 2. 0 is an interesting case, because if we multiply 2 times 0 plus 1, we're going to end up with pi over 2, and like we said before, at pi over 2, our velocity will equal 0. Next, we will be trying to use our original position function of f of t equals sine of pi times t over 2 to try to find our acceleration. We can do this because when it comes to a position function, the first derivative is going to find the rate of change for us. The second derivative of that said function will find the rate of change's rate of change. In other words, we'll figure out how quickly or slowly the velocity is changing as time continues. And we can do that by starting off with our original, well, not our original, but our first derivative to make things easier and to simplify. And we know from our first derivative that this parent function of cosine times pi t over 2 is going to equal, again, well, it's going to be different this time, I'm sorry, because we know that the derivative of cosine is negative sine, and we know that we're going to be left with another pi over 2 on the outside due to the chain rule that we found out earlier, and this inner function will remain the same. So down here we can see that. Now we have a negative sine times pi times t over 2 multiplied by pi over 2 times pi over 2. And further simplifying, we will find that the second derivative of our original position function is going to be negative sine of t pi over 2 times pi squared over 4. With this second derivative, we can now find the acceleration, because like I said, the acceleration is the slope of the tangent line of the velocity, and we know this because acceleration is how quickly or slowly an object is speeding up or down. And with this new second derivative, we can find the acceleration after 3 seconds of our original position function, and we do this by plugging in 3 for t and simplifying down. Again, using our unit circle, we know where sine of 3 pi over 2 is going to be negative 1, because sine is our y value, and using that, we will get rid of our trigonomic function here and replace it with a negative 1 times pi over 2 over 4. We're probably just going to leave this alone out here because it's going to make it harder to simplify in the long run. So we also need to bring down our negative, and we find that negative times negative 1, which is going to be a positive, leaving this at 1, times pi squared over 4 is what our acceleration is going to be after 3 seconds. And with this new function, we can simplify pi squared over 4, which is going to roughly equal 2.467 feet per second squared. And that will be our acceleration after 3 seconds. I hope you found this video helpful.